Chemicals play an important role in the field of engineering. Chemicals are dangerous if mishandled. Chemicals can lead to serious health problems. Handling chemicals properly must be done, and this is topic 11. Let us consider the Chemical Safety and Hazard Communication Program of Texas Instruments, Baguio City. Texas Instrument is a semiconductor industry. For chemical safety, number one will be the definition of words. Second will be the general properties and precautions. Third is regarding labeling. For Texas Instruments, they call it the Material Safety Data Sheet, or the MSDS. Fourth will be safety controls. Fifth will be the spill prevention and control countermeasure plan. Sixth will be the do's and the don'ts in chemical handling. And the last one will be storage and handling of used chemicals. The objective is to understand the potential hazards of chemicals, to learn the control measures being implemented to prevent potential exposures, to understand the importance of warning signs and the material safety data sheet, to understand the proper handling and use of chemicals, and to be able to apply the right procedures in using chemicals in the work area. Chemical is any substance with a molecular identity. Examples will be water and carbon dioxide. If we say pH, this will be the power of hydrogen. It actually measures the acidity or alkalinity of a certain solution. Acids like hydrochloric acid, sulfuric acid, and nitric acid will be having a pH that is less than 7.0. For alkalines like sodium hydroxide and potassium hydroxide, the pH will be greater than 7.0. A solvent is a chemical that can dissolve other materials to form a uniform mixture. Examples of solvents aside from water could be acetone, isopropyl alcohol, and the paint thinner. If we say corrosive, it is a substance that causes visible destruction to the human skin tissue at the site of contact. Examples of corrosive chemicals or solvents could be acids and alkalines. Any liquid or reagent having a flash point below 37.8 degrees centigrade means it is flammable. If we say flash point, this is a temperature wherein the reagent or liquid will start to be ignited or they will start to burn. Examples of flammable reagents or liquids will be acetones, methanols, and the paint thinner. If we say combustible, the flash point will be above 100 degrees Fahrenheit but below 200 degrees Fahrenheit. Examples of combustibles will be the fuel, particularly gasoline. The tendency or the ability of a liquid to quickly vaporize, or from a change of state from the liquid state to gaseous state, is volatility. Examples of volatile liquids or substances will be acetones and methanols. A material is said to be explosive if it produces a sudden, almost instantaneous release of pressure, gas, and heat when subjected to abrupt shock, pressure, or high temperature. Examples of explosives is the acetylene compressed gases. Chemicals comes with responsibilities to both supervisors and employees of Texas Instruments. Supervisors must maintain a list of chemicals that will be used in a particular area, and the material safety and data sheet also must be acquired, and supervisors also must be trained regarding chemical safety, and they have to assist in evaluating chemicals that will be used in their particular area. For all employees, they have to be informed on the potential hazard of chemicals that they may encounter in their particular area. Employees have to follow all environment, safety, and health requirements when working with all these chemicals and reagents. Employees have to read the label on the container of every chemical that will be used. Employees also have to check the material safety data sheet for detailed informations, or when in doubt, they have to follow instructions that are written in the labels of every chemical or reagent. For hazard communication, there are requirements. All chemicals must be approved by the environmental safety and health requirements before the chemicals will be entering the plant. No chemicals can be brought in visitors lobby or any other employee entrance. An information update should occur whenever a new chemical is introduced into the work area, including those to be used in construction. A current inventory list of chemicals must be posted in the work area, and it is also maintained by the environmental safety and health requirements coordinators. There are types of potential hazards. We have the physical hazard, wherein a chemical for which there is a valid evidence that it is a combustible liquid, a compressed gas, explosive, something flammable, an organic peroxide, an oxidizer, a pyrophoric, unstable, or water reactive affects the body physically, like producing cuts, burns, and others. There are also health hazards. If we say health hazards, this will be chemicals that will be affecting your parts of the body like the lungs, the skin, the eyes, or any mucous membranes. These are actually skin irritants, corrosive, sensitizers, and toxins. Health hazards also are having types like chronic health hazard. It means it affects the body through long-term exposure. If we say acute health hazard, it affects the body through short-term exposure. The body will be exposed through different ways. It's either through inhalation, ingestion, skin absorption, and injection. For inhalation, air sacs in our lungs absorb oxygen and other chemicals that are in the air into the bloodstream. Most common form of exposure is inhalation. If we say absorption, chemicals enter our body through the skin and other mucous membranes, particularly the eyes. It is the second most common type of exposure. Another exposure route will be ingestion. This is through eating and swallowing chemicals accidentally. Another exposure route is injection, wherein accidentally, maybe a person could be injected by a chemical. Chemicals have properties and precautions, particularly solvent chemicals. The properties will be they are narcotics in high concentration. They could be addictive, They could reduce pain, and it alters mood and behavior. They also can vaporize immediately when exposed to atmospheric air, making it explosive and fire hazard if exposed to heat or open flame. They also could be dissolved easily in ordinary plastic container, especially at elevated temperatures. What are the precautions on solvent chemicals? They have to be handled in a vented fume hood labeled for solvents only. They have to be stored in a chemical cabinet approved for flammable chemicals only, and should not be mixed with other corrosive or oxidizing chemicals. There must be no open flame or sparks in the hood, and all equipment must be explosion proof. Never mixed with acids or oxidants. It can create explosion and fire. We also have personal protective equipment, and this will be used most of the time in a particular area or department in Texas Instruments, like safety glasses, chemical gloves, chemical apron, solvent respirators, and other protective equipments. For the disposal of solvent chemicals, dispose pure solvent into appropriate labeled waste can or empty container of the same chemical. We must not mix it with other chemical waste or ordinary trash. These are a particular type of solid waste that has also a particular way of handling. For the disposal of solvent chemicals, we must not dispose them in a fume hood sink. Submit waste solvent to proper facility like the waste water or the waste treatment plant. For acid chemicals, the properties, the pH will be below 7. It is very corrosive, and it can cause tissue burns. They can irritate the throat after short exposure. Acids, when repeated contact will be done on diluted solutions, can cause dermatitis. Prolonged inhalation of its concentrated vapor can cause also inflammatory of the respiratory tract, leading to chronic bronchitis or even pneumonia. It also can cause some extremely dangerous sickness and health hazard, whether the acid is strong or weak. And as shown a while back, we also have to use PPEs or personal protective equipment in the handling of acid chemicals, like goggles and safety glasses, rubber gloves designated for a particular type of reagent like acid, and respirators also have to be used. Again, respirators must be designed for a particular type of chemical. For this example, it must be designed for acids. We also have acid-resistant apron, acid-resistant sleeves. Face shield also must be used when handling large volume of acids. And chemical safety shoes also must be considered. What are the precautions on acid chemicals? Do not wear contact lenses. Never mix with cyanides. It will produce toxic or deadly gas. Never mix acids with caustics or compounds of hydroxides. It will make a violent reaction. We never mix acids also with solvents because they can cause explosion and fire. The precautions to handle acid chemicals is they have to be handled all the time in a vented fume hood, only for corrosive materials. To dispose acid chemicals, it says here that we will never flush them in the fume hood sink. Contaminated absorbing materials should be properly disposed in a garbage container labeled with corrosive or acid chemical. containers should be properly sealed and then submit to their proper facility in the waste treatment plant. For alkaline chemicals, the pH is greater than 7.0. Alkaline or basic solutions, they taste bitter and then they feel slippery. It causes corrosive actions on tissues, causing burns and deep ulceration with ultimate scarring. It reacts violently with acids. Inhalation of the dust or concentrated mist can damage respiratory tract and lung tissues. What are the precautions? Do not wear contact lenses. Do not mix other chemicals not unless with an approved procedure. Handle all the time in a vented fume hood designed for corrosive substances like alkaline chemicals. For the personal protective equipment, we still have to use goggles and safety glasses. There still must be rubber gloves and respirators. We also have aprons, corrosive resistant sleeves, face shields also, and then chemical safety shoes. Hazardous chemicals and gases identification. All physical and health hazards of chemicals and gases must be identified with warning label through the material safety data sheet. The labeled minimum requirement for every chemical, what must be found there will be the following, like the name of the chemical or the solution or the reagent. There must be a hazard warning and precautions. The name and the address of the manufacturer must be placed there, and the equivalent proper personal protective equipment that must be used in handling this particular chemical. This is an example for propanol. Propanol is an alcohol and then it is labeled already. All the necessary information must be placed in the label of this chemical, particularly propanol. This is the label used in Texas Instruments. So let's proceed with the material safety data sheet. It is a standardized summary of the results of health and safety research on a chemical product. And there are different sections of the material safety and data sheets. I think it is having 12 sections. The first one is regarding the product information. Here, the name of the product, the manufacturer or supplier, the product use, the preparer's name, or it means the technician's name who prepared the reagent or chemical, and the date also must be placed all the time. For section 2, this is regarding the information of the ingredients of the chemical or the reagents that is prepared. For example, like hydrochloric acid, it will be stated there in the label regarding its ingredients, regarding the amount of water and then the amount of HCl. Second is the chemical abstract service number. There must be a code also to be placed there so that there's no need for employees to give the whole name of the chemical. Only the code will be written. Another to consider is the LD50 and then the LC50. If we say LD, it is lethal dose. If we say LD50, it is the lethal dose of killing 50% of a certain animal sample. For example, if we say LD50 is 10%, it means 10% of, let's say, the mice are dead when exposed to this particular type of chemical. For section 3, this will be the hazards identification. It considers here the routes of entry, the hazard symbols, and the potential health effects. For section 4, this will be regarding first aid measures. It should be indicated regarding the measures of each type of contact. For example, like if the contact is on the skin, the eyes, inhalation, and ingestion. For Section 5, this is regarding firefighting measures. This will be considering the flash point or the kindling point or the auto ignition point. Fire extinguishing media and procedures will be considered here. For fire extinguishing media, examples will be the fire extinguisher, and most fire extinguishers are actually having materials inside composed of carbon dioxide and other similar or related chemicals. For Section 6, this is regarding accidental release measures. This is regarding leak and spill procedures. For Section 7, this is regarding handling and storage of chemicals. For Section 8, this is regarding exposure control and personal protection. This considers exposure limits, specific engineering controls, and then the particular type of personal protective equipment to be used. For Section 9, this considers physical and chemical properties of the chemicals or the reagents used. And what will be found here are the form, the appearance, the odor, and other properties like specific gravity, vapor, and the boiling point, including the vapor density and the pH. For Section 10, this is regarding stability and reactivity. Those considered here will be the chemical stability, incompatibility to other substances, reactivity under certain conditions, and hazardous decomposition products. For Section 11, this will be regarding toxicological information. What will be found here will be effects on acute exposure, what will be the effects on chronic exposure, irritancy of the product, skin sensitization, carcinogenicity, reproductive toxicity, embroxotoxicity, respiratory sensitization, respiratory, it's just repeated, carcinogenicity, teratogenicity, and mutagenicity. For Section 11, this is regarding ecological information, particularly, let's say, aquatic toxicity. What will be its effect in water and the other living organisms there? For Section 11, this will be disposal considerations. So this is like treatment of the waste already before disposal. Section 14 involves transport information on how to transport the waste or even the chemical themselves. Section 15 is regarding regulatory information regarding its legality when it comes to these chemicals. And Section 16 will be other informations already that will be necessary for the plant to know. These are some communication, hazard communication card. We have here this National Fire Protection Agency. It is a warning sign placed prominently in areas of potential hazards. We also have the colors. If you notice, blue means health hazard, red is fire hazard, yellow is reactivity hazard, and white, there is a certain specific hazard that the plant will be placing. For the responsibility of the user, you have to read on the container of every chemical, check the material safety data sheet whenever you need additional information about how to control materials hazard or when in doubt, and we have to follow instructions that are always contained in the material safety data sheet. For the hierarchy of safety controls, we have engineering controls, administrative, and then after that, our personal protective equipment. For engineering controls, this will be control hazard from the source. Let's say from the scrubber, exhaust hoods, alarm, monitors, computer controls, and ventilations. When it comes to administrative, of course, the role there will be on trainings, procedures, audits, and some disciplinary action. For the PPEs, of course, we have to use the different PPEs like safety goggles, chemical gloves, face shields, respirators, including safety shoes. Chemical spills also can cause health hazards to workers, environmental damage, and fire, including explosions. Chemical spill response plan of a certain known chemical. So what must be done here is that the chemical must be identified. Second, we have to check the precautions and the hazards on the material safety data sheet. Third, block off the area with safety cones, barricade tape or rope, and report the spill to your supervisor or even to other workers. After determining that the chemical is not flammable or a health hazard, we have to shut off the source of the spill. We will use absorbent materials, sandbags, pads, or sodas to protect any nearby drains. Always check the material's safety data sheet and the emergency response guidebook for spill, containment, and cleanup information. Build a dike around the spill to prevent further spreading. Again, use sandbags, pads, or sodas so that it will absorb the spilled material. If the spilled substance or material is an acid or maybe an alkaline, there must be a certain procedure of treatment. For this particular case, for acid or alkalines, we will be applying neutralization. There must also be cleanup that will be done. When using adsorbents, we have to start at the outer edge, working towards the center. After the spilled material has been absorbed, it can be swept up and placed in a properly labeled disposal container. We have to store the damaged or the leaking chemical to drums or other containers inside a salvage drum. And always read the materials safety data sheet for the final disposal of the spill or the wasted material. For storage and handling of chemicals, for the proper storage, chemicals should be stored according to their characteristics. Corrosive chemicals should not be stored together with flammable chemicals. In other words, chemicals must not be mixed together even during the time of disposal. They have to be in separate containers. Stored chemicals should be properly labeled and covered, whether they are chemicals still to be used or even they're already waste. Storage area should have a spill containment and spill kit that must be available. List of approved chemicals should be available in the storage cabinet or room. Cabinets and storage room should be compatible with the chemical being stored. Chemicals should be transported in trolleys with spill containment and spill kit, and chemicals should not be transported using elevators. Empty chemical containers should be considered as full until they are decontaminated. Chemical storage room should be restricted to authorized personnel only. We have to know location of emergency exits inside the chemical storage room, and ventilation should be available inside all chemical storage rooms. Flammable containers should be grounded. Chemicals in each area must be limited to minimal storage enough for the approved chemical storage or chemical cabinet capacity in the particular area or department. These are some symbols used, like the health hazard. We have the flame. We have the exclamation mark. We have the symbol for gas cylinders. We have a symbol for corrosion. We also have a symbol for exploding bomb, symbol for flame over circle for the environment, and regarding the skull and crossbones, which means acute toxicity. What are the do's in chemical handling? Number 1, check location of eye wash and shower. Verify from supervisors if they are not functioning or if they are also functioning. Always wear the required PPEs. Contain chemicals that were previously used. Handle chemicals under a fume hood that is designated for a particular chemical. We have to discard containers that have cracks or chips. Mix or dilute chemicals only in strict accordance with the manufacturing specification or instruction. Store chemicals in cabinets or enclosures that is intended for a particular chemical. And clean up spills when they happen. And there is a particular way of cleaning up spills for a particular type of chemical or reagent. Use chemicals for their intended use only. Never attempt making experiments in the plant. We have to read labels on each chemical container. Label shows vital information for safe handling. For instance, like dangerous properties of chemicals and its precautions, what will be the type of storage to be done and the proper PPE to be used, and emergency actions for spills and disposal. What are the don'ts in chemical handling? First, do not be afraid to ask questions regarding chemicals, especially if it is your first time to meet them. If you need to ask questions or need assistance, you can contact your immediate supervisor. If frequently occurring safety problems are not resolved in a reasonable time, then you have to discuss these problems with your supervisor, with your immediate supervisor, like your safety engineer. Never mix acids with caustics, cyanides, solvents, flammables, including oxidants. Never add water to certain chemicals. Instead, add chemicals slowly to water. Never store acid containers together with flammable cyanides or caustics. Never pour waste acid into waste cans. Never use chemicals without wearing the proper requirement or the proper PPEs. Never carry chemicals in an open air. Never put chemicals on an elevation more than 3 feet above the floor, and never put mixed trash with chemicals. Never use flammable solvent such as an acetone or methanol for cleaning. Do not use chemicals improperly. Do not use chemicals for a certain job where it is not designed to be. Foods are not allowed inside chemical cabinets. They should not be mixed with these reagents, including laboratories where chemicals are always being used. And for Texas Instruments, usually they also check their employees by giving also exams or a concept check. These are some sample questions given to employees, and this is given periodically to check the knowledge of employees, because chemicals really have to be handled with care for safety inside a plant. To understand further chemical safety and handling of chemicals better, so let me share another video.
Introduction to chemical safety. Due to business needs, factories must keep many types of chemicals, and some of these chemicals may be dangerous if not handled in the right way. Mishandling chemicals can be dangerous, resulting in serious health problems such as cancer, nervous system disorders, internal damage, breathing problems, and so on. Chemicals can also damage your skin, eyes, nose, and throat. These can lead to loss of earnings as you get sick from being exposed to harmful substances. Mishandling chemicals might even result in a fire or explosion. You would risk losing your job if the factory burns down, and potentially cause serious injuries and even death. But it does not have to be this way. We all need to be careful when we store, label, and handle chemicals. And to make sure we and our co-workers are protected when using chemicals for the benefit of everyone. Aware. How do you know if chemicals are harmful or dangerous? Sometimes they are easily identifiable. For example, look around where the chemicals are stored. You should see signs in chemical storage areas and labels on chemical containers. Labels often classify chemicals as explosive, flammable, oxidizing, corrosive, having acute or environmental toxicity, carcinogenic, sensitizer, irritant, or gas under pressure. You might also see labels that are specifically for the transport of explosives, gases, flammable liquids and solids, and other materials. Sometimes chemicals are not so easily identifiable. For example, chemicals used and dispensed by machines are often unseen, or unlabeled chemicals may be used manually when you do your work. So the first thing you should do is ask and learn about the chemicals being used at your work. You should ask, A, what is a chemical? B, is it harmful or potentially dangerous? C, what does the manufacturer of the chemical recommend that we do to protect ourselves? If your work is to store, manage, and dispense chemicals in the workplace, you must be well trained by your factory management before you start your work. If you do not receive proper training, the risk to you and the factory is very high. You must become aware by learning what risks you are facing and how to best protect yourself and others from potential harm. Follow. Are there any chemical containers, large or small, in your work areas that are not labeled to identify what is inside the container? Oftentimes, you see reused containers of instant coffee, creamers, or water bottles being used as chemical containers, or chemicals in transit without proper labels. This is very dangerous and against the regulations. Every container holding chemicals must have a clear label indicating what is in it. Do not reuse any chemical containers. When a residual chemical is mixed with other chemicals, it may cause dangerous reactions such as poisonous fumes, fire, and explosions. Do not sell or use chemical containers, especially for storing food, cooking oil, sauces, or water for drinking or washing. It can cause devastating consequences to humans, making them sick and may even cause death. Used chemical containers should be properly stored, returned to the chemical supplier, or disposed by qualified contractors. It is your manager's responsibility, as much as yours, to inform and learn about the risks associated with each chemical, and to practice how to protect yourself and others. If the chemical requires you to wear personal protective equipment, called PPE, such as appropriate gloves, goggles, respirators, aprons, shoes, or anything else, then you must. If you don't, you expose yourself and your coworkers to unnecessary risks. The PPE you use must be appropriate to protect you. Inappropriate PPE is not only useless, but it can actually cause more harm than good. PPE information is included in the Material Safety Data Sheet, called MSDS, that chemical suppliers must provide to your factory. At a minimum, all managers and employees who are exposed to chemical risks must learn what the MSDS requires as PPE and safe handling procedures. Often you'll find that some of the required PPE is not comfortable to wear, but it is like medicine. Doctors' medicine or injections are not comfortable, are they? PPE is like preventative medicine. If you want to protect yourself and others, you must faithfully use the PPE. Like clothing, most PPE comes in different sizes. Your factory is required to give you a size that reasonably fits you, so be sure to inform your manager. Some PPE requires special storing methods for it to remain effective. For example, respirators. Respirator cartridges are expensive. When not in use, respirators must be kept in a sealed environment so that they do not continue to absorb chemicals and expire unnecessarily before their due date. Expired or damaged PPE should be replaced. It is your responsibility to know how to recognize when your PPE needs to be replaced and to inform your manager. You must learn how to properly use and store PPE. Be observant of other workers. Are they using makeshift personal protection devices, such as a towel wrapped around their face? Are any of your coworkers complaining of not feeling well, smelling odors, etc.? If so, talk to your coworkers and alert your supervisor. Being sensitive to those around you can also help you take precautions. Also pay attention to warning signs. Stay away from areas that use or store chemicals unless your work requires you to be there. If you find anyone smoking where the signs indicate no smoking around chemicals, or eating where the sign indicates not to, immediately alert your supervisor. If your work is to store, manage, dispense, and dispose of chemicals or hazardous waste, you must train specifically about the hazards. Your manager is responsible for making sure you have received thorough instructions, and you are responsible for learning and following the procedures correctly. Make certain that appropriate emergency response equipment and communication devices are properly maintained in any chemical storage area. You are also responsible for preventing spills and releases, making sure that wastes are disposed of safely, and being familiar with spill cleanup procedures. Waste spills involving large volumes should be handled by a qualified contractor. If you are not trained to handle large spills, you should at least be aware of how to control the spill before the contractor arrives. Protect in the case of an incident, such as spills, fire, and explosion. When you walk by areas with chemicals, take note to see if there are any obvious chemical spills, lids that are not tightly sealed, chemical containers that are dented, damaged or defective, or packaging that shows leakage. If you find something amiss, then you must notify the factory representative by following the instructions posted on the nearest emergency communication device. You must be aware of the different types of emergencies that can occur, and when it is safe to follow appropriate procedures to contain spills and releases. However, you must follow the evacuation and handling procedures you have been trained to follow. If you are aware of chemical risks, observant of those around you, and carefully follow the proper safety procedures, you can help ensure a safe and healthy place for you and your co-workers.